Everyone, it's Sorkin. Today we are going to solve LeetCode maximum number of vowels in a substring problem. So we are given a string s and we are given a string s and an integer k, and we need to return the maximum number of vowel letters in a substring of s with the length k. So what's that mean? Let's say we have a string s, a, b, c, I, d, e, f, and the length of 3. So we need to find a substring with the size of k with the maximum number of vowels. So in our case, this is the I. This is the substring of substring I. This is the substring of s, which is with the size of k, which has the 3 vowels, and we are returning 3 in this case. In this case, we have 2. Then the second example, because the maximum amount that we can make, the k is equals to 2, so maximum amount is 2. So for example, we can take any of these cases, and we are returning 2. And in this scenario, we are returning 2 because the maximum amount of vowel letters in a substring, li, eat, and ode, is 2, so that's why we are returning 2. So how we can solve this problem? Let's take a look at the brute force solution. Brute force solution is that we are taking each letter, and each letter we are checking that what is the, for example, we are taking this scenario A, B, C, then we are taking the B, C, E, then we are taking the C, I, and so on. So, and we are checking for each of these scenarios what is the maximum number of vowel, and we are returning the maximum one. And we are checking each substring. So in this case, the size of the array, let's say n, and the size of the substring is maximum is k, so it's n multiplied by k. So our time complexity is n multiplied by k, but we can do that in we can do that in n by using the sliding window. So we basically take the, so for example, let's take this scenario A, B, C, I, and I. So let's say this is our string, and we are creating a window with the size of 3, and we are calculating that what is the maximum number of vowels in this substring is equals to 0. So this one is equals to 0. So then we are extending our window and decreasing, we are extending our window, which means that we are adding 1 letter from the right and taking 1 element from the left. So now it increases to 1. So we have one vowel. So the maximum amount is 1, right? For this case is 0. For this case is 1. And for the last scenario is CII. So now we are again adding 1 more letter and adding to the right and removing from the left. So we have here CII, and the maximum number of vowels in this case is equals to 2, which we are returning as a result. Okay, first thing that we are gonna do, let's create variables max that we are going to return at the end. So we are returning this value max, and also let's create one more variable. Let's call it current, and let's also initialize that to 0. Now we are going over our array, and we are implementing our sliding window approach. So we are taking s I is less than s length, and I++. So we are going over our string. So first thing that we are doing, let's check that if our character is vowel. So let's create for that a separate function. Let's just call it isVowel, and let's pass there our character at which is S, which is I in our case. And if that is true, which means that this is vowel, we can increase our current, okay? So which means that we have vowel, this character is vowel. Let's actually implement that method, which returns Boolean, and is vowel. And we are passing there our character. We are passing there our character, and it returns either our character is equals to A or one of the vowels. Either it's A or E or I, and so on. So let's just copy paste this. So it's either A or E by requirement, and O, and I and U. I and U. Okay, if it's a vowel, we are increasing our current. Then what we do, we are going first until the length of the K. If the I is equals or more than K, and if it's a vowel, in this case, we are checking the I minus K. So from the left, we are checking. So we have our window now, and we are checking on the leftmost side the last element. So for example, let's say that we have size of 5, right? So we checked first 3 elements, and whether if that is a vowel, we are increased our current. Now we are going to the next element, let's say that the 4 element, and we are checking that the element at the first index, at the 0 index, if it's a vowel, then in that case we are decreasing our current. So we are taking that from our current, right? And we are taking that from our current. And that's it. And what we need to do, we need to update our maximum. So for that, we need to, our math, we need to take the maximum of current and max, right? And that's it. Let's run it. Okay, so let's correct this one, and also should be good. Yeah, should be current. Okay, great. So one more thing actually we can do. Now it works as expected, but one more improvement we can do. We can check that if max is equals to K, there is no reason to go further and explore the other options. So this is the maximum that we can get, is equals to 2. Number of vowels. If let's say that in the beginning of the string we found that that we have a substring whose all letters in that substring are vowels, then we can actually return that. So we return either K or max. Let's return max. Okay. All right. So let's check what is the time and space complexity of this scenario, of this case. So since we are we are going over the string only once, the time complexity is of n, and we are not using any extra space. So the space complexity is constant of 1. Let's go over our solution one more time. The problem is we need to find the maximum number of vowels in a substring of S with the size K. So to do that, we are using sliding window technique. So we are going over our string only once, and for each step we are checking that whether it's a vowel or not. If it's a vowel, then we are increasing our current, so which means that we are increasing the number of vowels. And since we are progressing further, after the I is more than k, we are checking the leftmost element. If it's a vowel, then in that case, we are subtracting from our current because we moved our window to the right. And for each step, we are checking that the maximum and updating that. If our current is more than our previous maximum, so then we are updating our maximum. Also, one more improvement that we did here, if the max is equals to k, we can return the max right away. And time and space complexity for this solution is O of n and O of 1 respectively. Okay, hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.